Alright, hello, welcome. Today I'm gonna continue working a little bit on the template because I wanted to do one more thing. So basically, last time we brought in a bunch of stuff that I've been upgrading sort of the base template with from my recent projects, and today I'm gonna do something that I've been wanting to do for a time, which is essentially replace the Raylib vector with vectors in Zig. So Zig vectors. So basically what that will do is make it easier kind of to work with vectors in some regard, and in other regards it might not make it easier, but we'll see here. It's going to be a little bit of an experiment. I mean, Raylib vectors, they do work. They do have some limitations when it comes to Zig, so they are not really like Zig friendly in some regards, but they are, you can work with them. There's no problem really. So they're but I just wanted to kind of, because my own experience with working with Zig vectors is that they feel, I don't know, they feel more easy to work with. So, and they are like proper Zig types and all that. So, but yeah, so what that will mean is that basically everything that I'm using. So first of all, I want to make like a vector thing. So basically we're gonna have a vector is the type vector 2 f32 essentially. That is vector 2. Now that can also be like, you can have like vector 3, vector 4, whatever. I could say, you could do this here if you want, like this, vector 2, 3, 4, whatever. Yeah, so that is a vector. Now, the good thing about this is that, let's say you have like a vector here, vector 2, and we'll initialize it to 0, 0 or something, or 1, 0, whatever. And then you have another vector, which is like 3, 1 or whatever. Now, to get like the sum of these vectors, you just say v plus u, and you will get the sum. In contrast to Raylib vectors, where you have to say sum equals v add u. And I mean, it's not that big of a deal, but once you start to kind of do, multiply, maybe you want to multiply by something else, you want to scale by whatever, it starts to become a little bit unreadable at first glance. So this is a lot more readable, I would say. Like, the only thing is with scale, you actually have to, because scale takes a scalar, multiply takes a vector. So with scalars, you have to kind of have a function like scalar 5. But yeah. So anyway, I just think that yeah, makes it a little bit better in that regard. However, I usually have, so what I've done before is I have like a library for vectors called v. So I usually do something like this, like you import v and you have like v.scalar, for example. Now I wish there was a way, maybe, I mean, I know that Zig is very anti overloads, and operator overloads doesn't exist. So, or operator, like defining your own operators for types does not exist, which is, I don't know, it's a choice. I get it. I get why they want to do it. They have good reasons. But if we had it, we could create our own type where we could say like v.scalar, so whatever, or potentially otherwise as well. Let's say you could define functions that take vector as the first argument, and then kind of treat it as, like in C# you can have extension methods, for example, or in Rust you have like traits or whatever. But to kind of define a function on a type, to be able to say b.scalar 5 or something like that, to be able to kind of use that, or well, scalar is kind of weird because scalar is just producing a vector from nothing essentially, but maybe normalize, for example. So you like do something like that, because what we have to do now is we have to say b.normalize from the thing and then provide the thing like this. And that's fine, you know. It's different. So basically what it means is whenever we want to do this kind of operation, like some kind of operation that is not a built-in operation, like plus, times, division, minus, there's also, you can do floor, min, max, you can do like, yeah, a bunch of these. We have to do it in this form instead of this form. So yeah, but I will take that trade-off because this is the most usual operation for me. So yeah. Hello Dialog, long time no see. Same in Odin, especially also when creating custom container structures, you can't utilize built-in length cap precision. Okay, I see. Yeah, it's a shame when you can't like extend the language like that. I kind of understand the philosophy there. I guess is like they want to keep the language simple and not produce a bunch of libraries that kind of totally change the language or something. I don't know. At least you can define vex as fixed size array and get swizzling and scalar like vector operations for free. Okay, in Odin, I might check that out. But yeah, so I mean, it would be cool if you could define, you know, some kind of vector type and then have, you know, a function plus or I don't know what it would be like, you know. Does this actually, I mean, you can actually do this, but yeah, well, you can't make it look like this. It's essentially just going to be a function named plus, but it's like yeah, self, you know, yeah, and then you would do like v plus u. Is that good? No, it's not. Yeah, this is not this is bad. But that's, I guess that's the extent you can do with operator. Operator, it's not really operator overload or whatever you call it. But yeah. Anyway, I was thinking also to kind of make this work sort of with, I mean, you can just make this work essentially with raylib. I mean, if we want, let's say we have a struct here called v, and we have the normalize function. We can take in a vector. Now the normalize also, this is like, you can't put any type in here, I guess, if you want to have it work on both vector 2, vector 3, and vector 4. I sort of get why overload Kevin bad. Yeah, I get it as well. I guess I haven't really experienced the downsides of it that much, but I can get the argument. At least the raylib bindings use a fixed array compatible with C struct, since it's based on positional fields. Okay, so Okay, so the raylib binding in Odin doesn't use the raylib vectors. Is that what you're saying? And we can do something like this as well. I wonder how this will work. So, well, we need raylib. In Odin, simply 2f32. Okay. And then we return raylib. No. Actually, we have a function to rl to raylib. Now this is, well, yeah. I have to do something like this. I mean, a function takes a type. And I will basically return switch. If it's vector 2, it's gonna be raylib vector 2. If it's vector 3, else unreachable. Or we could do compiler invalid input type needs to be a vector, something like that. All right, and then I mean we can also switch here. So switch type of t. We're gonna do to raylib. Well, let's get result to raylib type of t or v. I mean, no. Yeah, that returns a type. Hello, Penguin. Yeah, it defines them as 2f32, but fits into raylib vectors. Okay, so it can be just like bitcast. You can still access vector fields through Swizzling. Oh, cool. Good luck. Thank you, Piano. Good luck yourself. Okay, so let's yeah, we switch on T. If it's vector 2, we return R init. Yeah, I'm not sure if we can do the same here because of the vectors. I mean, it should kind of be the same. It's just a struct is. I'm not sure how different they are, like in their construction. Like an array versus a struct with 2 fields. Array of 2. Maybe it's the same. Because, well, it depends on how I guess it depends on how they construct it, like the layout of the thing. But I guess they would just pack it and then pad it at the end, right? That's the usual way, right? So wouldn't that be the same as an array? I guess the array would have to be packed. I don't know. We could try it, but I don't feel like it's going to be like a stable way to do it. Okay, but now we can turn a zig vector here into a raylib vector by using their own init function here. Or it's really a zig function, but defined in the bindings. But anyway, now we can say to raylib v.normalize. And actually, we need to convert it back now. Man, it would be so good if we could just bitcast it. We can try it. Yeah, it just feels unsafe or unreliable. I don't know if zig arrays are similar to C in that way. So an alternative here then to this would be to raylib we essentially just bitcast. Because that will not change the structure or anything. It won't, it only changes the type in, as far as I understand. It's like, there's no runtime. It's only like comp time. Works at compile, wait, what? Works at compile time if value is known at compile time. Oh, the actual conversion. Wait, what? But it should be just a type conversion, right? It's a compiler to bitcast a value of an undefined layout. Because I just said, because there's no, they don't change like the data. Okay, I guess we'll try it and we'll see. So let's just bitcast, and then we'll do back to v takes a raylib vector, and I guess we'll have to do the other way around as well. And that can also be now a generalized function. So we can say, what are you talking about, God Slayer? Are you talking about me? I have no idea what to talk about. I don't have another. That I don't recognize that consistency. Do we have a similar voice? yeah, map 0. We take a function that takes, actually, we actually need like 3 functions for each one. That's, because what I was thinking is like, just say that normalize equals, oh my god, map 0, raylib, vector, whatever, normalize. The problem is we need to supply 3 different, because there are 3 different versions of this function. Maybe we just, actually, maybe we just do this. Yeah. So this would be the declaration name. And that will give us a function that takes any type and return. Yeah, if you can make a function like this, I'm not sure if you can have any type there. We'll see. And then this is type of v. Can you do that? Return this type. I guess you can. I mean, I don't know. We'll see. And then this one is oh, so we do have similar voice. Okay. Well, it's not me, so also, okay. Yeah, I disabled the music because I noticed that a bunch of my videos were getting some kind of weird stuff happening on YouTube. Like with copyright stuff. So nothing seems to happen now because I'm not even monetized. So, but yeah, I decided, I thought that OC Remix, because they state on their website that there's gonna be, that you can stream with it or whatever. So, I don't know. It's, but I just don't wanna fight and stuff. What are you mixing? It's secret. It's a secret programmer juice. No, it's a little. It's some chocolate milk. I didn't make coffee today. Yeah, cold guy. Okay, you were right. I'll give you that one. It says, it felt like I should be able to trust what says on the tin, right? But apparently not. Okay. So essentially this will just be the same thing. So to v to rl v. No wait. We need a function, right? So we return a function. Function f. F takes a v. We return a type of v. We return 2v, 2rl, v. And then I think at field works for declarations, yes. Also this needs to be comp time. So we get the field and we call it. Yeah, that's it. And now we can just say, instead of doing this, we can say normalize equals map 0. Normalize. Why are you not a function? Why is this? Normally function calls also are yellow, I think. Yes, code guy, sure, why not? Let's say that. I think you're a little bit behind. Like on stream. Okay. Now, let's do a test. Let's do like let's do like one. I don't know. I don't know what this is supposed to be, but if we get a bunch of, if we get something that looks good, it should work, right? If we get something that looks like garbage, that's bad. So actually, we would need to know that. We need to know what it should be. Oh, it's my computer. That's you're hearing whatever you're hearing. It's my computer's fan. Is the only thing that's good. The mic is like right next to the computer. What are you going to cook today? So today I'm going to try to implement. I'm gonna replace the raylib vector bindings with my own vector library here. They're using built-in vectors in raylib. Is the fan sound loud? Okay, I guess we'll do it like this. We'll import first. I want to change this to vector 2. It didn't work. Okay. Okay, let's do this then. Let's do this. Why are you changing? Oh my god. Okay. Okay, that doesn't work either. Well, I want to do that, but that's gonna be a major thing. I just want to test this first, so let's go. Well, okay, let's do. Well, I want this here: vector mod import vector. Okay, we can also do v equals v vector 2 vector 3 vector 4. All right. Now, you feel like you're traveling in an airplane. Yeah. It's the ambiance. So it's either gonna be a loud, unless I get one of those mic holders that come down from the ceiling, which everyone seems to have. You're either gonna have to listen to very loud keyboard sounds. That's why I moved it now in the first place. Or, I guess, fan sounds. I could also enable noise cancelling, but then you wouldn't actually hear the keyboard sounds, which I think some people actually enjoy hearing keyboard sounds. I don't know. Alright, this is a const. There we go. That's why it was weird. Syntax. Okay, so that doesn't actually work. Huh. So it doesn't seem to be the any type. This type is like evaluated now. Or yeah, but it's not supposed to be evaluated. It's supposed to be evaluated. Yeah. Actually, you know what? What if because this function should always be the same type. So we could make a function of that type. Template function 0 takes v any type and returns the type of v. And let's just return v. Actually, this could be ID. Whatever. Okay, so then instead of saying this, we're gonna say type of ID. So now we can construct a type of this type. We just have to have a function of that type, and then we just take the type that we got. Cool. Great. Another thing that we can do, no, that's fine. Right, so that's map 1, map 0, I mean. Now add and all that is built in. There's just gonna be like other things like this that you wanna do. We could do things like round, like built-ins that take essentially this, like a bunch of these. Round, floor, ceiling. You have things like max and min. Although max and min actually, yeah, it works on like one vector. But the Raylib version actually like max, it works on 2. So actually we probably want to use that instead. And then we would need a map1 function. That takes 2 vectors. And actually you need to be the same type. And we will get this and call you. Okay, map1, and there's also map2, which takes yet another one. Maybe. Is there actually one of those? Actually, I'm not sure if that exists. But there is a scalar, but well, we'll add it as we go, I guess. So max and min are actually going to be map1. Oh yeah, and then okay, and then essentially what we could do is we can just do some testing here and log it out. So v is a vector to 1 or something. We can also add convenience functions to initialize. So basically we can have v2 is a v2, we take x and y and give us a vector 2, return x and y, v3, and v4. So v2, it's a little bit shorter, tiny bit shorter. 1, 2. Okay, so there we go. Now we have our vector 2, and now we can say, for example, v. Well, you can't say v dot because there's nothing there, but we can say v dot normalize v, and the result is u. And it does work. Look at the actual return type. It's a vector 2. Even though this takes any type. So it actually understands that you prefer vec2. But it's longer. Yeah, okay. Well, You get a vector. Okay, let me just show you. So if I change this to be 3, 1, 2, 3, where the hell did it? So now this is a vector 3. We get vector 3 from back from normalize. So that works really well. Okay, cool. Now I'm gonna keep it v2 because it's just, it's a vector library. So yeah. Well, yes, essentially. Well, there is, you can also, like, another way to have generics is that instead of having any type, you can have an actual type, but then you have to provide the type like this, which I don't like, because why provide a type when we already have the type? So and what you do then is you essentially, instead of having any type, you have a comp time t type that you pass in, and then v would be the type of t. So then you actually can, well, I mean, you can still get the type from t by saying type, or type of v is the type of v. So it's kind of redundant in this case. There's no language built in for kind of having a constraint on a type. However, what you can do is you can have, let's say we have like, we don't want like vector 2's in here. So let's say type of v equals vector 2. Okay, this is, then we can give a compile error saying vector 2 invalid type or something. Now this will actually be kind of like a constraint. So yeah, there we go. And now we get this compile error because the type was vector 2. So you can kind of define constraints like this. Well, you can define constraints like this. It's just a different way of doing it. It's just that you have kind of full control over how the constraints are like applied here. So yeah. Wait, no field name normalized in struct vector 2. What? But there is. Normalize. It's right here. What the hell? Well, it's not a field, it's a declaration, but this one actually says that it should work on declarations. Do I have to call? Well, okay. Maybe I have to do it on the type and then call it with this. Okay, that's better. It's one of those things where comp time is powerful enough to do these things, but with some more finesse rather than being a language feature. Though I would still love real language support. Yeah, but the thing is, this makes it so that you can kind of define language features yourself. You can kind of make them yourself. And also, yeah, the way they do like interfaces, like that kind of stuff, like because yeah, there's no like there's no thing like closures, building closures or anything like that either. So basically, all that stuff you have to kind of do manually, but you can construct, you know, make it like as a kind of library for doing those things, which gives you a very powerful, like basically open-ended way of doing things. And it also it kind of feels like you're close. You feel very close to the low level stuff. Does it give you notification when someone joins your stream in Twitch, or you see them after they chat? I don't get a notification. I can see how many are watching in total across the board, across the streams, and I can. I do have alerts enabled on Twitch now. I just need to BRB 1 second here. We'll continue. All right, I'm back. Same in order, you have to roll your own closure system, though you can define generics in different ways, compile time constraints. Okay. Downside is although the compiler errors for constraints appears at declaration rather than call site. Yes, that is actually true of Zig as well, although it's okay, I'll show you. If we take this back, this constraint here, so basically if type of v equals vector 2, then compile error, vector 2 error. Okay, where's the error? Oh, wait, there we go. Okay, now we get the error. No? Wait. Oh. This needs to be type of V. Also, this was in the wrong place. There we go. Now we get this error. So this happens here. However, there is also a thing reported here, but my error kind of I have like I did a custom kind of error reporting for like looking at the diagnostics of the compiler, so I don't actually get this, but you do actually get the thing. So if I do the same build here, I should get now you can see we get this error, and then you also get referenced by, so you get kind of where this came from. So all the places that kind of reference, like you get the whole call stack essentially of that. So you can kind of find, you know, you can kind of trace back to find, okay, where was the source of this call. If I was to have this like in my kind of error, whatever, scraper, whatever, it's just checking, it's just getting this one. It doesn't actually parse these things. Don't think Odin does this? Yeah, that is like one of the gripes I actually have with the way I've set it up now, is like things like that is not really working for me that well. That's also the case like in the standard library. You have things like, if you let's say you provide a string here, this will actually be like an error, except I don't see the error here. I have to kind of look in all errors, and I get an error over here, which is like, hey, you kind of format, yeah, you get some error because we have the wrong formatter. So if I improved the error reporting, I would actually get this error right here. And I also saw that Jai, I saw like a video on a person who had access to Jai. Jai seems to have even better reporting stuff for, or even better, I should say a similar thing, but you can also like kind of decide where the error is supposed to show up. And Jai also has, it seems like the same as Zig, where you can like define types in comp time and do a whole bunch of stuff. That would be cool to try at some point. But I think it has, I was thinking like, oh wow, so maybe it has more utility than Zig, but I don't actually think it has. Not from what I've seen right now, at least. It might have, but okay. But anyway, this seems to work, at least from a type standpoint. So I'm just gonna remove this constraint. It's a stupid constraint to have. This was just for testing. So what I'm gonna do is I'm gonna log out this, And we're gonna say or log u. And we can also, to test this here, we can say like, okay, let's make a vector 2, 1, 2, and then we normalize to see if it's the same. But then we need also one other one. All right, let's see. And it works! Ooh, yes! So then we don't have to do a lot of conversions back and forth. Awesome. I want to check, does it work for like vector 3 and 4 as well? Yes. I'm gonna assume it works for 4, but I'll test it anyway. Just if this somehow the structure is like different or something. Yeah, it seems to work. Okay, cool, awesome. Nice. That means we can simply have that just, you know, this is just a bit, the bit cast. I mean, I think it doesn't do anything in runtime, if I understand correctly. It might change. I don't know. Because it says here, works at comparative values. No, if it's a component to bitcast, a value of undefined layout. Like this, I don't understand. What do you mean works at compile time? If value is known at compile time, there shouldn't be any like data conversion. I thought that that's what this was doing. Converts a value of one type to another type. Return type is inferred result type. Asserts that size of type of value equals size of dest type. Type info is not equal to pointer. Use pointer cast. Yeah, this is the only thing that I don't understand. It's like if there is like if there's like runtime stuff to this, then it's basically kind of moot, maybe. But let's, I guess, yeah, whatever. I guess we'll find out if it's an issue. So I can test with this library a little bit, and okay, but now is more of a tedious task of actually replacing everything with this. So yeah, and so we'll basically do this, and now we're gonna get a bunch of errors. Already in here. Yes, so these are vector 2s. And we'll do that. Actually, here we can just pass this in directly. Actually, if it's a vector, do we pass it? We do pass. But that's an array. Okay, I guess it's a we pass in that. Color, yeah. All right. Vector 2, pixel size, vector 2. Yeah, so this would be that. And scale is actually going to be times. Oh yeah, we need scalar. Ooh, okay. The scalar is actually bad. Well, I guess we could. Well, we have to make 3 versions of it. So this is one thing. I really wish Zig allowed you. So this would be a feature that would be awesome. If you had scalar like this, and you had X or whatever. Or let's call it S. Why not? Now, it would be awesome if we could here say result type. Because the type would depend on where you use it. Because then we would simply say return splat S. Because the return type of this depends on, well, it says any type. I mean, I don't think we can have any type here. I think you can't actually have that, which is unfortunate, because I really wish you could do that, because then you could do this and you can essentially just use this as that. However, it will also, this won't work here actually, because we don't know the result type, because we're in an expression. So actually it doesn't work. Okay, whatever. But yeah, we need like different versions here. We need like scalar 2 gives you a vector 2. And essentially all of these are going to be the same. We just splat S. Whoops. Scalar 3 is vector 3. And scalar 4 is vector 4. And here we have to actually use the correct version. Okay. All right. Another thing here, int from float. So basically, we could define convenience for this. We could say to int and then here we can actually provide a comp time. So here you kind of decide which type you want. Oh, actually, that could be the way we do it here. That you can also do this. If you have a scalar, a generic scalar, you can have comp time t type. So this is if you don't actually have a thing ready, you return t. Yeah, so splat s. That you can also do that. I mean, I guess we can have that as well. So here, but t is supposed to be an int, and we give a vector of some kind. It could be any type. And then this would actually be to int type of vt and to int. Actually, I'll make these private so we don't get these confused. Yeah. And we won't actually need these. Okay. Also, that's what you could do here. No. Okay, so 2int, this gives you a type. We get a type. Actually, this is the int type, and then we get the vector type. Here we return a vector of length something. I'm not sure if that has that. Oh. Okay, let's call it t, I guess. Actually, does vector 2 have length? No. But we can say type info vector dot vector dot length. Yes, we can. Okay. So this would be type info vector length. Simple as proc scalar 2, scalar 3, scalar 4, which select the correct procedure based on usage. Nice. Is that working with Odin? Yeah, that's the thing here in Zig. There's no overload. That would be awesome. But the problem here, there's another problem though here, is because this is like part of an expression here. So the result, and the Zig, in this case, the result type is actually unknown, unfortunately. So there is no one correct solution to this issue here. So that's why I have to specify what type this is supposed to be. Because otherwise Zig wouldn't know. Like if I just said splat here, which is supposed to use the result location to identify what type we get. It says that splat must have known result type. So even if you overloaded it here, there's another issue here that Zig doesn't know which type to choose. So, but this makes it so that we actually define, okay, it's gonna be a vector 2. They don't call it overloads. This doesn't actually overload existing features. Yeah, okay. But it's kind of defining a function, an overloaded function. It does the same thing, right? Because overload is essentially just a group of functions that you have to pick the correct one depending on the types. Does it work for return types as well? Like the result type. I mean, let's say you have 3 functions that have the same signature except the return type is different. Can it choose the correct return type? Kinda. Okay. It looks at the input and return type. Okay. Cool. Nice. Because that means that you can define a function, but then also there's no such thing as traits or type classes or anything like that, right? I was thinking you could define the function pure and it would return whatever is needed. Like you can essentially wrap a value into a monad. But then you would have to know all the, like you have to define all the functions that it could be. Like, can you extend it? Can you extend? You can take like a proc, like over like that thing. Can you extend it to include others as well? Scalar 2, scalar 3, and your scalar inside an expression using make 2 will select scalar 2. Nice. There's typecasting, but I already work with raw pointers. Okay, so you can't combine one of those procs with another proc to make it a new proc. Once defined, it's static. I mean, I guess it could, yeah, I guess it wouldn't matter because you would have to use the new proc. Right, and because it's static, that means you can't generate it either. I guess you could use a code generation, but yeah, you can always use code generation. Okay, it's nameless. Okay. How would you use it then? So you can't define it? And bind it to an identifier? Do you have to say proc every time you want to use it? Yeah. Yeah, okay. Yeah, but how do you use it later? How do you call it? I guess I could look it up. Okay, to int. This takes a vertex and simply int from float. That's all it is essentially. We just need to define the type correctly here. So there we go. Now we have a toInt there, and then to get the screen size as an int, we will say toInt i32 screen size. And actually, does this work? Screen X, screen Y. That does work. Cool. Yeah, so you could do width height equals toInt i32 screen size. There we go. Because this kind of deconstructs or destructs the thing. Okay, so you can bind it to a name. Right, it has to identify as a group. Right. Okay. Cool. Oh yeah, the rectangle. That's also a whole other thing. The rectangle. The rectangle is so simple, struct. We probably just want to make our own. I guess in this case, yeah, there's not much here. Like, there's only 2 functions. I mean, if we just replace this, we have a fully functional rectangle that does the same thing. But here we can say position is a vector 2. Oops, and size is a vector 2. And that would also kind of be the same struct, I think. This could also be like bit casted. And in it, we will take position and size. I think so. Okay, one thing here that is no, because these are actually not structs. They are just vector 2s. Yeah. So it should be fine, I think. Check collision, yep. So self, other. Of course, it should be from our elements. Alright, and then we can have a bunch of other convenient stuff as well for this, but I'll add it as we... Yeah, so now we can extend this if we want. I'm gonna go to game, we're gonna define a rectangle. There we go. It's also such a nice pattern to just have game, have everything. So then you only need to import game to have access to basically everything you need. Okay, this is gonna be this. Just not to confuse with other types of things. Now, draw rectangle. So, yeah, I wanna also have versions of these functions, I guess. Or we could say game rectangle position size to raylib. Some of these are easy enough. Like I wouldn't say game v to raylib. Like that's too, and that doesn't actually work. You have to say game v to raylib here. Yeah, that doesn't work nearly as well. This is probably. See, that's the nice thing about having a struct. You can just do this instead of having a built-in, like a primitive kind of type. It would be so nice if you could like make functions work on like primitives, but yeah. Or maybe even like sort of maybe wrap a function or wrap a vector to in a different type, then operators would still work, but you could define different functions on it. I don't know. Anyway, yeah, let's. I want to replace these with this. I mean, essentially, we could just replace vector. Okay, let me. Can you do? I don't know. Hello, Infinite Coder. What's up? What's up? What's up? I guess we could do like this. That will get a lot of them at least. Oh, and there's another one we can do. Let's do like this or this. It's gonna give us the one we had, yes. Yeah, so now, well, we can either do game v vec2 or we can do this. Which works as well. Oops. Right, now, does not support field access. Okay, so what we can do is we can actually do screen X, screen Y. Because I think that if we, oops, if we tried to do this, I don't think this works because of recent changes to the language. At least that's what I thought. What? I really thought this was impossible. That you had to, that like index access was not actually possible on vectors. You had to convert it to an array first. What the hell? But yeah, okay. I guess we'll keep it like this, see if it works in the end. There might be other compiler errors we have to fix before that's actually an issue. But here, for example, instead of dot multiply, now we can say like this. So it does this, and then we add the position. A little bit nicer. Here we can just say that. Yeah, let's have this as a convention. I like this. V2 is like when you don't have a result. Okay, now we can use this one. Should be a whole bunch of other errors. Oh, I guess we'll add that one. Why did oh? I thought for a second that I accidentally removed E here, but then I remember that it's there because of shadowing. Now we have a new one. We have semicolon. Nice. Okay. And gravity X does not exist. I guess we'll try this. Okay. We have all this crap here. Now this part, actually what we can do here is we can say, let's just try this. Hitbox min is round V2 okay, this wasn't actually as elegant as I was thought, but that should kind of do the same thing. And then we have hitbox max. No, hang on. Actually, give me this. We have size, we have position. We can just say hitbox. Well, actually, we could just say min. We could have like a min max function here. Gives us a vector 2. Actually, it's just position. Max is position plus size. That doesn't work. Does not a guaranteed in-memory layout. It's because it's extern. But vector 2 is... Wait. But this is also external. Isn't it? Maybe it's not. It is. This doesn't have a guaranteed layout. Or this has a guaranteed layout. But this doesn't. Is it because it's larger than 64 or something? Huh. Okay, okay. Let's just... And I guess this would be the same here. If it was used, I guess. I don't know, we'll see. Min x min y. Yeah, so this would just be hitbox.min. Max is round hitbox max. Okay. And then min. This is going to be to int usize. And then clamp x. Right, so we can kind of make a new one. We can say like grid clamp to grid, and min is div floor hitbox min divided by cell size. Does this work on vectors? I guess we'll find out. It might work, it might not work. And then max is same thing, clamp to grid. And here we use ceiling, which I think is wrong actually. I think that was one of the fixes we made. It should still be div floor. Okay. So all that is replaced by this. Now we just need to make this work on vectors. Let's make a from int as well. Here we don't need a type, we just need a vector that is from int we take the vector type, we take the length, and then this is f32. And then this is float from int b. Okay, now we can say size is from int, and then we don't actually need to specify what the type here. We can just say from int width and height. Okay, that's the size, and then here we pass in this should be component wise, I'm pretty sure. Yeah. Okay, so that should be good. And this one is like, I mean, I think we have to do this. Or this. It doesn't really matter. Okay, there we have clamp to grid. Now over here also, right, we need to make all these things. I mean, all right, sure, whatever. Let's do this for now. I just want to kind of make this work for now. Okay. Now, let's make you a game rectangle instead. And we'll make everything vector 2s. You can now be offset and size. So much nicer to just work with vectors instead of all components all the time. Position is actually it's just this. Set position, size, really this struct is actually not necessary anymore. So I'll probably remove this, but yeah. Okay, let's continue. Axle union vector field was struct is active. Okay, where does, okay. That comes from over here. Oh, right. So I have to kind of turn it into a vector, I guess. I could also make you know what? What if v2 took any type and then these are, and then we do like converge component. Is that a good idea? That would lose the result type of each one, but I think that's probably fine. No, this is any type. Gives us F32. If can we have like is like meta is can we do like math is integer now? I mean, we could do type info type of a if it's an int. Is that a thing? Yes, it is. Okay. So if it's an integer, we get bits assigned that nest. Well, we will simply return float from int a. If it's a float, and if f bits is not equal to 32, that's a lot of bits that you can have. U16, 2 to the 16 is that 65,535. You can have 65,535 bits. That's a lot. That's a large number. Let's do return. Return like this, so we don't have to actually spell return every time. But this one, we actually do really need to return. Oh well. Well, actually, not if we do this. And then if it's another, if I do a float cast, otherwise we just say A. I don't know if I like that formatting, but yeah, that's okay. If we have anything else, I guess that's gonna be an error. Actually, is comp time int a thing like this? Yes, it is. Okay, well, I guess here we could just return A because it's gonna. Well, okay, let's just float from it, I guess. And then we have comp time float as well, I think. That's just gonna be A. I think that should work. And if we have anything else, that's going to be a compiled error, invalid component type. Type name, type of name. Okay, now we go back here, and instead of saying from int, we can actually just say v2, pass in these as ints, and they will be automatically converted. Oh, we have a new one. Except that doesn't actually make sense. And actually we don't need to do this, we can just do that. Okay. Yeah. Right, let's do game rectangle. I still feel like this gonna blow up here at some point. The index axis of vectors, I'm gonna get a whole bunch of complaints. Screen size. Oh, this is a rectangle, yes. So we could say game rectangle init URL. So here we will say this, and then here. But then that needs to be negated. We could take save this. Is it I32? What is it? Yeah. Position. Actually, let's do const x, const y. So x and y. Now, actually, we do want these functions to be public. I just realized because of this here. All right, we're almost there. I'm gonna try and make a little game after this, so we can test this out a little bit. Right. Rotate. Yes, rotate is a thing we want to have for sure. Yeah, rotate takes... Well, it actually takes a scalar. I guess it's kind of unique. Rotate takes a v and then radians. And then we do 2rl v rotate angle, and then from... Yeah, I'll actually rename you to from RL instead. Yeah. So then we do rotate v1 by rotation, and then we add position. Oops. But here we also need to do 2rl yeah. I'm gonna make you this, and then destination, just do this, and then you just call 2rl. Okay. Okay, so what do we have here? We have a bunch of points. We scale them. You know, a scale could be a function on here as well, I guess. Could be. I mean, we could call scale like this, because this uses some kind of weird math library. Or I shouldn't say weird, but... Or we could just say v times scalar type of vs like that, and that will just scale it. Scale u by scale. And then now is there also, because now we need to wrap this with rotate as well. So that's not this is not the nicest pattern. I will concede to that. And then in the end we add position as well. We could do maybe position plus, and then do that maybe. I mean, you're not supposed to look in here. This is where it becomes messy, like when you want to convert to the other thing as well, and also when trying to do a lot of things at the same time, which are unconventional here. Although technically scale, we can also, instead of doing scale, what we can do is take this times scalar I think that's probably better, yeah. Just trying out different things. What's that relative position? Yeah. All right, what do we have here? We have the camera. Camera system still kind of rudimentary. Right, this is just plus. Cool. Great. What do we have here? Does not support field axis. Yeah. Is this the last thing? What? Okay, I was 100% sure. I was like 200% sure that you couldn't. Oh. Okay, something seems to have broken. It might be the grid thing. It might be this. Wait, how does this work? Because... Wait, why is this not called anymore? Oh yeah, because we're doing these. Right. Are we calling this? Yes, we are. Let me just double check here. The candidates. So hitbox min is just min x is just x, min y is just y. Max is just plus size. And that's what we're doing here. Position is min, position plus size is max. Okay? And then these things are like min, x, max. No, min, x and y is clamp to grid, but we also floor, div floor, min with size. Yes, that should be the same thing. And then min x, min y, max x, max y. Should be the same thing. I mean, the gravity and everything else seems to actually work, and it's the collision that seems to be spooking here a little bit. You can just enjoy the drone sound in the meantime. I need to find some kind of playlist that doesn't cause me copyright claims or whatever. Clamps. Wait, is that it? That can't be it. There has to be a lot more. Okay, but I'm pretty sure it has to be something in the grid stuff here that went wrong. Oh, you know what? Also, this whole thing, we can, now that... No. I'm just kidding. No, actually, what we can do here, we can actually speed this up a little bit. But yeah, we can actually do this because each operation should be applied. Each operation applied twice. That's not like we can apply it once with vectors. So we still need to grab out. So basically, let's say we have a target temp, and this one is vector which is gonna be equal to S. No, not S. It's gonna be equal to target oh yeah target 0 and target 1 dereferenced. Then we're gonna apply operation provider element is a vector 2, pointer element is pointer to vector 2, operation I'm gonna call this VOP. The target is target temp. And then VOP is apply operation provider element is game vector 2. Active field name is tag name T. This is void. We will apply the operation and then target 0 equals target temp 0, target 1. Okay, because essentially this operation could be a bunch of stuff happening. So instead of applying the operation twice, we apply the operation once, because this is where probably this could be a heavy operation, let's say. I mean, I guess it depends, maybe. But now we just create a thing on the stack that represents the target, and we apply an operation on that target, which will work because these are vectors, so they will apply these over several values at once. And then we set the target back to where they were. So essentially, because we have a structure of arrays, we're kind of turning one part of, like one item of that into a struct and then back into a structure of arrays again. That's essentially what's happening. Okay, and then we want to do the same thing over here. But this one, we actually have a value to give, which is s, which should be vector 2. And then we basically do the same thing. And yeah. So the only difference really is the operator that changes here. Okay. Cannot assign to a console. What? Oh. There's the dereference. Yeah. There we go. Okay, so now potentially you can, let's say we extend this. This only works for like these built-in stuff now, but you can also extend it. Let's say we add an operation called like map or apply, or I'm not sure. Yeah, apply. And this is a function that takes basically the function will take I guess we could just take like provider element, I guess. For now. It doesn't have to be the same, but yeah. So we apply this function. This will take the current value and then transform it however it wants to a result, and then that result will be used. And then we can make this here apply. Takes a function. All right. And then over here we have apply. We'll simply set the target equals Oh yeah, because this works for. No, yeah. So the target is actually. Yeah, because now we this like converts the target, right? But here the target is actually gonna be the same. So I think here we could just say F. Well, it's apply. So it's gonna be apply. Or F. It's F. Yeah, we get F. And this is just target. Okay. All right, but that does not really solve our issue. I just wanted to extend it because I've been thinking about it a little bit. Okay, so we can see that it kind of does some weird thing over here. I'm pretty sure this has to be like grid. The grid thing does not actually work correctly, unfortunately. So, yeah, and I'm not sure why. Hang on. Could it have something to do with the fact that now that we're dealing with vectors and not structs with x and y, that the vectors are, when they are kind of part of a struct, let's say, like a rectangle, like this, sometimes I feel like the data gets lost because this is kind of like an array, and I know that sometimes when getting a copy of something that is supposed to have an array, it doesn't actually copy the array. So I'm gonna try this out. Let's say that we have a rectangle somewhere. So for example here, we're just gonna log this out. I'll add a format function. Actually, that should work. What? Wait, it's not even called. Okay, well, let's try here then. Okay, there we go. It does seem to be correct here, yeah. Okay. And then I guess we can also, in the end, we could say, okay, min and max. So that should be cell coordinates. Okay. It's not wacky numbers. It seems to be okay numbers here. Eight to. How many are there? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, I think 4. And then first is A3, then it's A, or A2, then it's A3. Yeah, so it seems to work. Okay. Interesting. So apparently it seems to work, but then this doesn't work. Maybe. Or this. Do we have 0 axis? No, that can't be true. I think this worked before, so yeah. Yeah, that's false. So we should go in here actually, yeah. Okay, I have to actually press it at the right time. The right time. Don't know what happened there. We don't seem to find any solids. Did I forget to set this up again? Why did... What's going on? Okay, we did get one. This is, yeah, it something is weird here. Let's check out the data. All right, yeah, that looks good. What the hell's going on? It feels like as we're approaching to the solution, maybe. Well, hopefully. It feels like I'm missing something super obvious, but I changed so much that it's gonna be hard to kind of pinpoint where the issue is. Everything I've looked at so far seems correct. Eight, 3. Well, this one is like 4, 5, 5, 6. So that should hit something. That's probably the player falling down there. It should go from 4, 6 to 5, 6. Okay. Okay. I'm getting my spider senses are tingling here. What if this wasn't actually correct here? Min X. So min x, min y, max x, max y. It should find the solids here. It seems correct. But it doesn't go over here. It does. It's. Wait, max. This should be +1, right? This is exclusive. Oh, wait, but then. Oh, I found a jump. Still doesn't say solid here, which is strange. Oh, because it goes to 5. No, yeah, so now it should go to 5 plus 1. So it should go to 5 to 6. Well, it should just go to check 5. And then the other one should check 5 and 6, which should give us this. But it doesn't. I'm just gonna grab a glass of water. I'll be right back. All right. Hello, Packer Wrap. You're mopping the floor. What? This doesn't even check anything. Oh, because this one. So it should be like +1? Wait. Also, these are U size. Yeah, actually, it should always be at least 1, right? Unless the size is 0, I guess. Oh, the noises. I think I just sat down. Or something. I think I moved my chair. like this. Okay, well, let's just add one, because... But then it's always non-empty though, so it doesn't even make sense to call this. I mean, we're still looping through. Yeah, let's just remove this function. There we go. Okay. Oh my god, what is happening? Okay, so found solid. Yeah. So we do return if we actually found something. And actually, since we're doing X first, okay, let's just do separate. Let's just separate them. Yeah, so systems, but they are separated. Okay, so they are separated. So we are doing one at a time. I'm basically, so what I've been doing is like I've been refactoring a little bit on the vector library, and or I've been implementing a vector library, and that's made some changes throughout the whole thing, and not the very least this the grid, spatial grid collision detection stuff, or collision resolve collision stuff. So yeah, that's I'm trying to debug what has been introduced here. But I think also we had some old, maybe like things that didn't actually work the way I was thinking either. For example, I think this should be like this should be 1 minus 1. But that doesn't really do much for us right now. There's another issue going on. It's like the resolving is kind of pushing too far. I think it's the X. The X resolves first. So let's say we've gone into the ground a little bit. It's gonna resolve X to push us to the left or right. And then Y. Is it the other way around? Like we should do Y first? But then shouldn't that be the same issue if we're trying to move into a wall? Because then you move into the thing, you might encounter a wall, a ledge. That's not supposed to be a ledge, it's just between two tiles. And you get corrected up or down. And then you take X to be corrected the other way. Man, I was sure that was working before. So no, that's right, because you only move in X first. That's right. You don't move in Y. So this doesn't even make sense. Like quantizing the grid for magnetic alignment. Yeah, sure. That's exactly what's happening. Yeah, because we only move in one direction first. That's the whole point as well. We update X. The question is, does this actually work then? It should work. If we're X, we're doing a bunch of X stuff. If we're Y, we're doing a bunch of Y stuff. Yeah. And here... No, wait. Yeah. We only do X or Y depending on here. There should be one axis. Yes. Should only be X or Y. It could be this part. But it shouldn't be, because the pointer I want should be 1 and not 2. Just double checking everything here. But that was not the issue, I don't think. This never happens, really. What are you up to, Packer App? Have you been making any arcade games lately? Yeah, we might not be able to make the game here, unfortunately. Man. Why is it like this? Was it add or was it subtract? I'm pretty sure it was add. It's gonna launch. Yeah. So first the thing should happen is we check X. We move X, we don't collide because there's nothing, there's no wall. But there's a ground. So we move Y, we collide with Y, we correct upwards, but it doesn't seem to correct enough. Okay, it might be that we get more candidates than we should. Actually, that might be the issue. But then we should also get like a weird behavior on like just up here as well. Perhaps, maybe not actually, maybe not. Okay. Let's take a look at here again. So first we round the things. We do a div floor instead of ceiling here though. I guess, what if we do a ceiling like this? No, that just makes it worse. Max oversize, ceiling, clamp. Okay, I want to check here. We land on the ground. Press space. It should like check those two. So here, for example, we're at 5, 5, 5, 6. So 6 is the ground. So essentially that is wrong then. So 5, 6, it shouldn't be 5, 6. Or, I mean, I guess it could still be 5, 6, but... No. Wait. This is the first thing here. So 5, 5, 5, 6 is... This is when we correct X, I think. And that means we're already in the thing. So that is bad. So it kind of means that the frame before update. Update position, we update velocity as well. resolve. And after we're done, we end the frame. Excuse me. I was thinking if like the velocity y was somehow kept intact. So it's set to 0 after correction. Next time, gravity is applied, so we still go down into the thing. But we shouldn't move down until we're down here. Start physics frame, we apply gravity. That shouldn't change their like position. That only affects acceleration. Right, so when we go in here and we update position X, that should not affect Y. Because we're X, we're only doing stuff to X, yeah. And resolve X. Yeah, Kepler, sure, but it's also like if you only update position X first, and then check for collisions on X to move the body back, because we went into a wall, for example. We don't want to go through the wall, so we have to change X. And then we update Y to see if we collide with a floor or a ceiling and correct there. If we do update X and Y at the same time, that means now we can actually go, like, let's say we go into the floor and then we correct X. So now we have a collision, but the collision actually happened because we moved in the Y direction. So there is a difference between updating X first and resolving X first, resolving collisions first on X only, and then checking Y second and resolving Y collision second. There's a difference between that approach and the other approach, where it's to update X and Y simultaneously and then check for collisions. So that is, yeah, from what I've read, a usual issue with tile, like grid spatial systems with tiles, that you would have to kind of separate those two updates. Yeah. Alright, I'll have to BRB 1 second here. Be right back. Okay, man, this. Okay, I just have to kind of think about this from the beginning. But what is the issue? So I mean, there should always be like at least one candidate, because the position itself, the point itself, should be a candidate. But we do, I think we do get too many candidates. Probably, yeah. It's like when we check collisions. Where is that happening? No, it's not checking collisions. It's more like we're converting the max into a thing. But let's say cell size is 32 by 32, and let's say hitbox min is 00, max. Let's say size is 32 by 32, right? 00 plus size is 32 by 32. That's the max. But we should actually take like -1 from that, right? Because no, maybe not -1. The 32 should be like it should be like it's like divided, it goes to 1 1, but that shouldn't be the case. It should just be enclosed in the thing. It should just be 0 0. Do at some point abs floor max in the values and therefore get a twist? Abs floor max. Well, I don't do abs here. So basically what this is doing is we're taking a coordinate in world position and we've divided the world into a grid. So we're taking the world position, we're basically translating world position into a cell, like a grid position. So essentially just dividing world position by cell size. That's all this is, essentially. And also flooring it, because we need it to be an integer. Yeah. I'm trying to figure this out. This was working at some point, but I think it was a fluke or something. I'm trying to figure this out. I can't just take -1 because then it won't. I mean, I guess I could take -1 and then min it or max it with min. Yeah. Okay. Max with min, and then you are -1. Okay. Sure. That seems to work. Okay. That's a wrap. Okay, but I think, yeah, now what we've done is we've essentially changed kind of the the vector system to work with raylib stuff, raylib types, I've replaced the raylib vectors with zig vectors. So now we have a vector library which uses built-in zig functions to do stuff. These are kind of unnecessary though, because you can just say @ceiling actually. I just realized. So we can actually just remove these. Unless we want to change out the backend or something like that. No, let's just remove these actually. Yeah, that doesn't make sense. And I'll also remove scale because that doesn't make sense either. Max and min are vector, or yeah, that normalize, rotate. Those are from raylib directly. So then we can keep. So yeah, we're using this library now that uses some functions from raylib library to be able to have some functionality left there. And whatever we need, we can bring in later as well. All right, so, and we also made this rectangle struct, which essentially can replace hitbox as well. And it's used for conversion from into a raylib rectangle. So it's just easier for us to work with position size, having our own vector types there, and we can also extend it with more stuff if we want. And yeah, so now we have that. Okay, cool. What I think I want to do now is make a game. Okay, I'm just gonna refill my water and we'll be right back. I have an idea for a game. How does that change compute location? I assume Raylib would utilize GPU if you kick it for benefit of doing zig and then. Well, I don't think the vectors are on the CPU. I mean, they are utilizing some kind of math library, and I'm also I'm using the same functions for things like normalize, for example. So, for example, here normalize is actually, well, normalize is the same function that they are using. So for things like normalize, rotate, for example, rotate is just using, it's just an alias into their rotate implementation, which uses this thing here. I'm not sure. Ray math, yeah. But this one just calls the C library. Yeah, this is just a wrapper for the C library. So that calls vector rotate, which is an external function from their library. So we are essentially using their. It's just the vectors themselves are not really stored on the GPU or anything like that. And the main parts there that are used, that are like sent off to GPU, or like the drawing and that stuff, that's still all Raylib and stuff like that. This is just how to kind of how we kind of talk about vectors, essentially. Okay, but let's see. I'm gonna update that. Implemented vector lib, rectangle set. All right, cool. So now we can make a new game here. I'm kind of into JRPGs, so I'm gonna make like a JRPG kind of minimalist thing. All right, here's our thing, and yeah, it should be like exactly the same as the template project we were just in, but now it's copied over here. So there we go. Now we have the same kind of thing going on here. But I'm actually gonna disable the CRT just to have it a little bit different. All right, now let's go over here and I'll remove the Sobel thing. We don't need you. We don't really need to do any of this. All right. Cool. So yes. So also we go to preset, and the preset should be top down. Oh, there's an issue here. Oh, I never fixed this part. Oh. Okay, well here we do apply to acceleration. X, let's do this one at a time. And you will be add input times speed. Okay. And this one is just add speed. And this is subtract. Okay. So now we have like a top-down thing instead. Okay. I will go to draw. Now we have like draw background. I'm just gonna disable this. I'm pretty much sure we're clearing, yeah, we are clearing black, so we should have a little thing happening there. Okay, cool. I wanna disable, yeah, the grid is also, I'm just gonna do this. So everything's off. We're gonna change that later, depending on. So now we can move this around here. Now I kind of like the kind of, you know, you're not like, well, I kind of like being locked into a grid. Like I'm a classic Final Fantasy, 2D Final Fantasy guy. That's my jam. So I want to have that kind of thing. So I'm gonna go to platform, no, controllable, top down. I'm gonna make a new one called like jrpg perhaps, and then we can just use that for future jrpg likes if we want. So this is jrpg. All right, I guess we could upset, we could like do this one. Okay, I'll just copy this. All right, systems. No, that's fine. Components, controllable. Copy this as well. All right. There we go. Cool. Yeah, so now I want to implement this kind of grid-based movement. So I think what we need is we could have a speed. We could have like we could have like a counter that counts down the number of pixels we're moving. So like move counter and I guess we could have like next move at, and we can also have wait, what was I thinking? Oh yeah, direction, which we probably actually want a component that is a direction component. Well, we want like a direction. Sure, there could be a direction here. What is that called? It's called orthogonal? No. Is it called orthogonal? Direction. However, the direction is kind of now part of that component, I guess. So actually, no, let's just do it like this. All right, so direction is, I don't know, right to start with, or down is the classic, so that they face the camera. Just curious, did you think about considering using shaders for matrix mass transforms alternative later on? Well, maybe, but yeah, for my kind of, if you know, if I want to implement something that requires even more optimization, I might look at that. But for now, I'm using like SimD is enough for the physics stuff. So yeah, I can have like plenty of stuff on screen and there's no issues. For now. It depends on what game you're making. But I'm not gonna pre-optimize. I'm not gonna like optimize without having a goal. That matches like what the project that I'm trying to make. So I'm not optimizing just for the sake of optimizing. Okay, so let's see. We have these things. All right, now let's go controllable system. Yep. All right, so the thing is here, we really don't need a physics system here, essentially. We just need a grid system. And the position is actually more like a grid position now than anything else. So actually, we could probably just get away with having the position here. And the position could be like it could actually be an integer position. Although we would like to have maybe no, let's just keep using this. I don't want to complicate things too much here. But we certainly don't want to use acceleration or velocity, because I don't want to show like sub-pixel movement. I want to have the pixels be pixels, not sub-pixel movement for this one specifically, for this project. There might be other projects where I want the other way, but this one I don't want that. So basically what we want to determine here is which direction do we want to move? Can we move? Like, are we already moving, for example? If move counter is more than 0, we can't really move. But what we do instead is we say if next move adds less than game elapsed time, not really time, but time, then we will say move counter is now -1, and then we set next move at is equal to elapsed time plus yeah, I guess this would be some kind of move duration. We have to kind of let's set this to, I don't know, 0.2. Okay, but if we can move, then we want to check. Okay, so left x-axis, if left x-axis is less than 0 or is down, move left, then we want to say direction is left and move counter is whatever is supposed to be the kind of grid cell size. I guess we could just put it on game, maybe. Actually, we could do grid. No. Physics. Grid. Cell size. Oh, we don't have the thing. Let's just remove that. And I'm gonna assume that it's the same size on X and Y, so U size found F30, right? So int from float. Actually, it's kind of weird that is F32, but anyway. Well, it's weird in one way and not weird in another way. Okay, so that now we can kind of move to the left. I guess we can try it out. I'm gonna disable all of this other stuff. Oh, and also let's head over to update. So control was happening up here and then physics. So, but physics is like less important now. I think that we could probably update position here. Probably not really matter. So move counter, I'm gonna say whenever we change the move counter, we also want to change the position. So we're gonna say that we want to apply to position X and we want to subtract 1. Okay. And there we go. We have our little... Oh, it never stops. Oh, there we go. Oh, because the grid is 32, right? It should be 16 probably, maybe, not sure. Cool. And then the... Let's change the player. Player is 16. Okay, cool. Let's change move duration. Let's do like maybe like this. A little quicker. All right. Maybe even quicker than that. Okay. All right, that feels good. Now, let's do the other directions. So we have X, we have also I'm gonna do like else if, because you're not supposed to be able to do more than 1 at the same time. Or we move right, then we'll change direction to right. We will also move as well. Else y is less than 0 or move up. Then we are going up. And otherwise, we're trying to move down. There we go. Oh, should definitely be up. However, this part is only moving left. So we have to change, or we have to check like what is our direction. So switch direction. If we're left, we need to do this, and so on. Right, we need to add one. Let's do up or down, and both of these are Y's. There we go. So now we can move up, down, left, right. I can hold down. We're locked to this grid. Okay, let's also draw the grid as well. And the position of the player have to be now a multiple 16. So take like, I don't know, 10 and 6. Now we should like be aligned. Yeah. Cool. Draw. I guess, I mean, we could draw the grid. Even if it's not solid, let's draw like with lines. That's gonna draw all the grid lines so we can see that perfectly aligns. Cool. All right, now, well, I don't really want to draw the grid though. I just wanted to see. I'm gonna make, well, okay, I want to make kind of the map then. We could try to do something like Perlin, like procedural generated, like Perlin noise. So let's see. You know what? Do we have? Do you have noise? No, you don't. Is there like a? Oops. So what I'm thinking is essentially, let's do a, I guess, map. Oops. So the map could have like tiles. Which I'm gonna make a thing like this. And constant tile, yes. No, yes, no, yes. Tile, we can have a tile type. Let's just make this an, well, it could be a union. So we'll have like, you know, mountain, grass, or plains, water, whatever. And even, you know, a city or some kind of yeah, city that could take you to another area, but I'll add that later, maybe, if we have time. Alright, so we have the tile type, and I guess that's it for now. Now I want a function that is like generate. And I guess we'll take in like width and height. Okay. And then essentially we just wanna grab like some kind of height value from like generate height from X and Y. So we essentially just go through width and height, and we generate height, and based on that height, so let's say height goes from 0 to 1. So let's say that if height is less than 0.3, we're gonna populate the map with water. So we'll make a map here. Actually, we need allocator as well. No. Okay, and then tiles is gonna be, sure, let's make this allocator, allocate tile width times height. Alright. By the way, the more I watch you use Zig, the more I get a feel for it. The syntax is lovely, right balance between JavaScript, Swift, Java, Spring, Rust. Delightful, just generally thanks for sharing. Yeah, okay, no problem. That's cool. Yeah, I really like the syntax. I mean, it took me a little bit to get used to, but I certainly, yeah, I really like it. Okay, I don't get why people call that C replacement language-wise, technically sure, but the language design definitely its own thing. Yeah, I mean, I think it's just because of how similar it is. Like maybe, like syntactically, it's a little bit similar, but it's also, you know, maybe closer to modern languages, of course. But I would say it's mostly because of the features it has. Like, and also it, like, you know, it interfaces very well with C because it's so close to C when it comes to like, yeah, the kind of philosophy, I guess. Well, I guess the underlying structure beneath. So if H is blah 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 blah, then map tiles. Okay, let's calculate the index here as well. Map tiles I equals to. I'm just gonna say init water, or just dot water could be. Else if H less than, I don't know, 0.7. Let's do like something like this, so the planes is pretty common. Then it's gonna be planes. Otherwise, we have a mountain. Cool. Cool. Now we need this generate height function. X and Y, and we do need some kind of state as well. So I think what we need is like a random here. So I'll put a random here as well. And I'm not sure if we probably need a pointer to the random, or maybe not. No. Put the random here. Now this random can be used to generate random numbers. Alright, but we need some way of generating a noise, and I don't have that in my brain. So I'm gonna look up some kind of algorithm for this. Probably noise algorithm. There's other types of algorithms as well. There's probably also like a library as well, but let's check it out here. Okay, what do you have to say, algorithm? Or, I mean, AI. Well, you are an algorithm, so. Eager to dive in, especially F5 with C. Haven't seen yet how it is done once I'm done with renovating. Alright. Yeah. I mean, it's pretty simple, actually. It's actually pretty cool how easy it is right now. To calculate noise value, blah, blah, blah. What the hell is this? Okay, we got the grid cells. Right. Just give me the thing. Probably noise 2D. This is the implementation of in the Python library. Alright, let's just see if we can translate this here. Oops. So we've got probably noise 2D. We probably need sound in here. Alright, so we have an init function. Okay, we have a list range 256. So we have range 256. That is shuffle. So it goes from 0 to, so basically, yeah, 0 to 256. We shuffle it. Okay, so that should be doable, I think. We have a seed. So seed is a, I'm not sure what it is. I'm gonna say it's a U size for now. We need random. And we probably need to store the random here as well, probably. Or we could also, yeah, we could actually make our own random here. If we take IO and we'll have random is a random, and we'll have IO. Actually, we don't need IO. We'll just return random is it's gonna be random. Actually, what we need is the IO. This is like IO source. That's what we need here. Yes. IO IO source. IO is IO. All right. So that is that. That's. But the problem is the IO source, I think. Actually, maybe we don't want IO source. There should be implementations here somewhere. Let's just use this one. Yeah, here we go. Oops, what happened there? Actually, yeah. This is random. Yeah, let's just have random here. So this would be random, and then this one. Yeah. Because if we use IO, it's gonna depend on like other factors. So it's like gonna be, we don't know what the seed is. So here we can actually initialize with the seed. And the seed is a U64, so now we know that. Okay. Now, and this also, yeah, so we don't need to do that. Shuffle P, self-permutation P, okay. Well, let's make this random over here then, so we can use it straight away. And then I'm gonna set you, actually you are just random, I'm gonna set you over there. We are going to say random shuffle, and these are, I guess they are U sizes or something, I'm not sure what they are. Let's say U size, like an int. And the buffer is our range, or P, I guess. And, well, let's just make P be a list of 256 U size. And we will loop through. Actually, is there a range? Is there like a P length? And actually, we can just do this. No, because we need I as well. Yeah. Pi equals I. Okay, and then we shuffle that. I'm not sure if this is 1 indexed or 0 indexed. I'm gonna guess it's 0. Okay, and then we shuffle. And then we have a permutation equals P times 2. Is it going to go through every list? Okay, so we have permutation as well, which is a list of 256 U size. And this would be permutation. Okay, and then we'll go through this again, and we'll say permutation I equals Pi times 2. All right. That should be that one function there. Okay, now we have, I'm just going to do this. So if we have something def and a name, why is this not working? Oh, there we go. And we have a thing. we can say pub function that instead. There we go. And also this is probably a U64, perhaps. I'm just gonna assume everything is U64 for now. This one though, not sure what this is. I mean, in Python it's just going to be a number. I guess lerp depends on T, V. What is V? Fade for curves. Is it utilizing like wrapping and stuff? Here we're flooring, so obviously this is like floats and stuff. I don't know. Okay, maybe these are floats actually. Yeah. Let's just make everything float here. It's just a C that was the other thing. Grad hash val. I guess this is also a float. Maybe. Convert hash into one for generated vectors. Sure. This might be some translation issues. And here we can use add floor instead. If what? Oh, if so x if this is true. Okay, y if this is okay. All right, permutation. Yeah, we need permutation as well. We don't need IO. Self is unused. Well, then we actually don't need this at all. We can just say, whoops. That. Okay. Maybe this works. Who knows? Because I don't know what types they are using, but I'm gonna guess it's like an F32 or something. So, yeah. Also, yeah, we have the permutation. So the permutation is just static, I guess. It's just there to kind of decide the noise layout. And yeah, okay, because they're doing like a whole bunch of these bitwise operations. 255, like it like truncates everything. Okay, well, I don't know. Okay, all right. So generate height, right? So we need, well, okay, actually now we don't need random, we actually need like the noise. And we don't actually need random because we can just make a noise here. We could put a, I guess we could put a seed in here for it to use. And here we create the noise, which is gonna be import this one. Okay. It doesn't actually need to be mutable. Yeah, because we don't actually change it after. All right, and then here we can just pass in the noise. Oh. And we essentially just return this. Now these are floats, so I guess we'll do this. And now I'm not sure about the resolution here, if we're supposed to put in like very small adjustments or large ones, but what we could do is like divide this with some sort of zoom. So we could have a zoom factor, which I guess we could set to 1 for now. And we'll divide by zoom here. Okay. There we go. Now we should have a way to generate a random map of water, plains, and mountains. And if we go to game, or let's go to setup, or actually, yeah. And then we'll add something here. We'll add a map. So I'm also going to add this type here. And so we'll generate size of the grid. I'm not sure. Let's just do 10 by 10. Seed. I'm just gonna pick 0 for now. Or 1, 2, 3, 4. Alright, so now we should have a map. Just need to fix some stuff here. Incompatible types. Oh, you are F32. Map is a constant. Wait, but it isn't. Oh, wait. Okay, sure, let's make it variable. And also we need to return the map when we're done. Wait, yeah, because I was thinking like this should be fine, because this thing is the one that is not. Oh, it says constant. Okay, sure. Well, actually, let's make the tiles like this then, because this is not constant. And then in the end, we will turn tiles. Yeah, there we go. So it becomes constant. Essentially. Invalid operands binary bitwise float and comtime int. Yeah, see, this is where I don't really, I'm not sure how Python is doing this. I'm just gonna do this, see if that works. Still invalid. Can we like float cast? Or do like as F32? Okay, it can't actually do bitwise expression float with float. I'm gonna check this here with Python. So Python bitwise operators between float and int. $14 years ago. Oh, that's if you want to overload yourself. On integers. Well, that's what you say. Oh, hang on. So first they're flooring. This might actually count as converting to an int. I see. So x is supposed to be an integer. So let's make these integers. And here we actually need to convert to a usize int from float. Right. I'll just do this here. There we go. Whoops. Okay, now we have some other issues. So x and y, they are ints, and these should probably also be kind of ints, maybe or maybe not. I'm not sure. They should be floats, right? Because you're taking a float minus an int. That should be a float. Fade. Okay. Right, and we're also using, so p is a usize red, yes, and then yeah, that makes sense. Okay. You are a usize. Right, yeah, that makes sense. So maybe the first one should be a usize. Makes sense because we're doing an and here as well. And now you have no issues. Okay, there we go. It's a little bit tricky there converting from Python because you don't know what the types are at first. Okay, we got some runtime issues. Index out of bounds. All right. So we're out of bounds. I wonder how that works in Python if it wraps around. Perhaps. But maybe that's why it's doing this though. How can that become 386 if we AND by 255? Oh, because we're doing plus. Yeah. So this is from 0 to 255. This can be also 0 from 255, so plussing them could potentially be longer. So why are we doing that? I don't know. I'm just gonna mod it, I guess. See if that works. If it works, then great. Because this might be implicit. I could also look it up how Python does it. I'm just guessing here. Because I know they have some weird stuff going on when indexing arrays and stuff. Okay, so that worked. I mean, it didn't crash. Okay, so now I want to have. So we have the map now. So I want to draw it. So let's make like draw map. So we'll get the map, and we will go through map. We probably need to store width and height here. And yeah. Oh, excuse me. It's X and Y. Now it's probably better if, like, we can draw it. We can draw it once to a render texture, so we don't have to generate like the texture every time. But yeah. Anyway, so here we have that. Now we need to get the tile. That's going to be map tiles x plus y times map width. And then we'll switch on the tile type. If it's a mountain, we're going to do something. I'm going to just grab a color here. So it's a mountain, it's going to be brown or gray or something. If it's a plain, it's going to be green. If it's going to be water, it's going to be blue. Oh, I did it wrong. Thing there. There we go. And then we're going to say draw rectangle. Let's do rec, I guess. And color, and this is gonna be X and Y, and the size is the grid size. All right. Cool. And then we need to call this function. So let's call this here. Oh, yeah, jrpg. There we go. All right, so now we should be drawing the map as well. Hey, we got some stuff happening up there. Okay, I forgot a crucial thing here. We also need to times this by the cell size. There we go. Okay, we got a bunch of water. Cool. Okay. I guess we can increase this a little bit. Maybe even more. I'm just gonna make it so we see the whole thing. Okay, so we got a bunch of water. Maybe it's because the values are not what I expect, perhaps. Backtrack. The game rectangle in it passed as a parameter when it is executed. Is it queued in sequence of parameters executed immediately? So, well, it is so. Well, I don't exactly know how Zig like compiles this to assembly code. I mean, it uses some kind of intermediate language as well, but there are a couple of steps before something actually happens here. But I don't know. I think, yeah. I mean, it is executed near here, I would say. Essentially, all it's doing is just constructing this thing with these values, this structs here. And I mean, it also depends on if it's runtime. Like these are runtime values. Actually, this is kind of like a comp time, actually, not value, because this never changes here. We're returning a comp time value. So this is comp time known, and this is not comp time known. So this is runtime known. So there should be things happening in runtime here. Yeah, no problem. Okay. So why are we just getting water? Let's look at some of these values when we're done. So let's log out a bunch of these. Let's just do any tiles so we see all the tiles. Let's see what they are. Oh yeah, they are water, right. No, I want the value here, yes. I want the H. Zero. Interesting. So there's probably something wrong with the noise function. Probably. You and you. Okay. Or are we supposed to pass in? No, I don't think there's a problem passing in. Like, we could try to zoom in, see if that helps. Okay, we're getting something else. Great. So let's zoom in a little bit more. And there we go. We get more things like maybe what I expected. Okay, let's zoom in a little bit more. Okay. Now we get like an island. Cool. Another thing that these things usually do is if you have a camera, we follow the player. Yeah, now we're feeling like a real jrpg almost here. Okay, with proper procedurally generated terrain. Let's zoom in a little bit more. Let's see if we can get a mountain here. Okay, these values are a little bit more up and down, I guess, now. But we don't really get too high. But they do go above 0.5. I mean, maybe we just need to move over a little bit. Let's zoom a little bit back out. And we'll have an offset. Let's just do like offset X is 100. Yeah. Okay. Whatever. Let's just start there. Okay. So noise, but if we already offer follow, how about aspect ratio independent action frame follow? Scroll only when reaching limits. Aspect ratio independent action frame follow. Yeah. So basically, you can't go past the edge. Yeah. Yes, that is obviously better. Good suggestion. So we could get the map. And we can say that, well, we kind of need this pixel size, position. We also want to see if, so what would this be? This would be like, we're gonna do some min-max action. So max and min. Okay, and max is something, and this is something here. So max is so that's the bottom. That's where yeah, that's the min value that we should put in here. So the min value would be pixel. It will be like, it starts at 0, right? But then we also want to add this as well. So I think that, no, pixel, yeah, over 2. That is the max there. And we also want to round it. I think if it's, yeah, so if it's slightly negative, it's like negative 0.5, it rounds it to -1, which is not great. No, it's not gonna be that. It's gonna be 0.5. Yeah, but then the position, wait. It should be floor, I think, perhaps. All right, and then we have min. So this would be the maximum amount. So min and max. I'm gonna call this the target. Now max is like pixel size. So this would be half size right, and this would be like map width times cell size x. Let's just grab the cell size here. Negative half size. So that's the map right is map width times cell size x. And map bottom is height. Alright, and then this is the target. And then you are map right minus half size. Oh yeah, that's right. I forgot about this. There we go. And of course, you know what? Let's add a convenience function here called size that gives us a vector 2. Return game vector 2 width. Alright, now we can say map size. Actually, let's do like map max is map size plus or times cell size. There we go. And then you are actually map right or map max 0. There we go. And then we'll do it on the way here. All of these are 1s now. All right. And then you are the same, I think. Yeah. Okay. There we go. Let's see if this works. No. Okay. Okay. Target should be good. Half size of the screen. Yeah. Min is half size of the screen. Yeah, that should be true. Max is the max of the map minus half size. I don't see where the issue is. You can also do this. Target is actually half size, pixel size over 2. Well, it's 0, 2, 3. And then target is position minus half size. And main is floor half size max. Like that. And then essentially here we just say actually, and then here's the adjusted so it's all the same. Okay, we got same issue. Okay, so something did happen on X here. Seems like that actually does work. I mean, we can move out. Y does not work though. That's very strange. I mean, it almost looks like the map is kind of drawn at the top right or top left. What about, where is the actual camera? Offset is 0. It's not the offset that needs to change, right? Let me say, sometimes can be helpful to track the types in the variable names. Yeah, I'm not really a big fan of that, to be honest. Like, it can be good sometimes when I have multiple variables with the same name, that, or I need to convert one variable into another type, just because it's zig and you sometimes it helps doing that. then I would add like a little, if it's an integer, I'll add like I underscore or something like that. But most of the time I don't really need to do that, I feel like. Yeah, so now it's the question, why are we all the way up there? Is this supposed to be... No, it's not supposed to be negative. That will be... Right? The other way around. It's just the other way around now. Wait, are we adjusting correctly here? I mean, obviously not. Yeah, I mean, it could be a good... If you feel like you want it, I don't, you know, tell you what to do, but, you know, me personally, most of the time, I have pretty good, you know, if I don't know what a type is, I could just go and check it, although this says unknown, so... But yeah, apart from that, I could go and look at, okay, this is a vector 2, you know. Most of the time you can kind of guess from context. Oh, you Google search is not, oh my god. Thank you for telling me. Okay, let's go through this. So we have the map size, we have the cell size. The map max is size plus cell size. Okay, then we also have the screen size. We have half of the screen size. And the target that we want to do is position minus half size. Min is just the half size. And max is map max minus the half size. That makes sense. So if we didn't do, if we just did target instead, I'm just gonna double check if this still works here. There might be something wrong with this. No, so this still works. Wait, what if these are false? What do we start with? We start at, of course, the thing at the right. Yeah, the thing at the top left is 0, 0. Yes. What values pixel size scalar 2 actually have? This one. So it's like an array. It's like 2 values. So basically, it's like pixel size. So pixel size is kind of like the game resolution. Like each, because we're kind of zoomed in. Well, essentially, it's the world resolution. You have like 1 pixel in the pixel size means 1 pixel in the world. but not necessarily on the screen, because we can be like scaled up, we can be zoomed in. But it means 1 pixel in the world, and so it's the half size of that. Now, because we're zoomed in, the target X and Y should correspond to world coordinates and not like zoomed out or zoomed in or whatever. It should, yeah. So that should still be world coordinates. So this is world coordinates. It's like half of the entire screen. I'm just trying to figure. So I know that there's no issue with that. That works because when I just set it to the target, it follows the player exactly how we want it to do. So the problem is with the adjusted. So yeah, if I run the game now it's perfectly following the player here, right? So the thing that we need to do is we need to there's something wrong with the adjusted part, because when I set it to this, it doesn't adjust it properly. So I'm trying to go through this over and over to see why this is not working here, because as far as so target should be correct. Now min is like, what is the minimum pixel that we can be, and it's going to be half size, because the half size means like half the screen, right? And if target is like the center, but let's say this is wrong. Let's say it should really be like 0 here. Let's say min is 0. That means we need to be able to move further up. Oh yeah. Let's say that this is 0. Maybe that's more correct. Maybe that is the issue. This is 0 instead. I was thinking that, yeah, okay. And then max is gonna be, well, I can still with floor, I guess. Floor is gonna be like, I guess half size is not actually part of the equation then. Or is it? No, it's gonna be negative pixel size. Yeah. What happens if you simply toggle follow based on range? I'm not sure what you mean. Okay, now it works. So yeah, turns out the Y coordinate is not, yeah, the map is too small for, so let's increase the map a little bit, I guess. Let's try and increase it by a lot. Probably take a little while to generate, but okay, here we go. Still at the top left here, of course. So now we can go around and explore our procedurally generated map with no mountains. Maybe we'll encounter a mountain somewhere. Okay, we have reached the end of this island, but fortunately we can swim in this jrpg. That's usually a thing you get like way later. But here we go. Oh, here's another island. What's on this island? Nothing. Great. Let's go down. I mean, maybe there's like a dragon on that island, like a dragon cave. Instead of doing a full check as you just flip, toggle the follow boolean, and based on the resulting screen position as you render, this would be the uno reverse of your implementation. Okay. Yeah, I got it working, so it doesn't matter now. Okay, this looks like an egg. This is now called Egg Island. This looks like a giant egg. maybe there's chocobos here. Egg or... yeah, it's an egg. Cool. So there you go. There's that. Okay. Cool. And we can change the seed. So if I change the seed to something else, now we get an entirely new world. And everything is water. Okay, you know what? I'll increase the speed a little bit. This was the original, so I want to keep that value. Let's do like point... whatever. Every frame. Okay, still pretty slow. You know what? Then let's do this. Let's go to control wall. Now, where are you? Here. And let's do... instead of doing plus like this, we're going to do plus equals. And that should be a lot faster. Next chapter, introduce height maps. Procedure generated as well by same Perlin noise. I mean, these are height maps. You essentially are looking at, like, where there's water, the height was lower than... 0.3 or whatever it was. I don't know why there's so little mountains though. Maybe you have to zoom out more. Or in, I mean. And also, let's do this. Let's just change the zoom to be like small, so we see the entire thing. Holy shit. Okay, that was way too small, I guess. Hello Zinx, what's up? Never use Zig, but are you not using delta time for movement that feels smoother? Well, the reason why I didn't want to use that was because I wanted to kind of have the old school, like, per pixel movement. Okay, well, here we can see the entire world. Still no mountains. What if we zoom in a lot more? Okay. The thing is, I think also we need to, I think what we need to do actually, we need to kind of maybe divide by some kind of ratio or not, or something like, because when we zoom in, sure we get height, but not the height maps. A semantic interpretation is used for each type of terrain. Well, you're not gonna go more detailed. Like, this is the kind of amount of the... well, okay. if let's say we go into a location, but that's not really how JRPGs work, I guess. Like you would go into a location, the location would be like hand designed. I guess technically we could do procedural locations as well. I mean, yeah, sure. That could be actually kind of cool, like procedural towns and locations, caves and all that. Right, so I mean, I guess we could say this. To get some mountains. There we go. You can kind of see, you know, where it ends up. 0.5 should be even more. It just looks like big blobs, but I guess that's, yeah. There's also like other types of generations. I mean, I guess it does work. So what if we zoomed in a little bit more? What happened over here? It's like you just zoom into the same thing, really. Oh, well, okay. So the kind of what I'm thinking is like the mountains are just gonna be blocks. Like you won't be able to just move through a mountain. Essentially, that is more how I'm saying it. Like that's the classic kind of, you know, JRPG way. Like you can move on plains, but you can't move through water if you don't have a boat. You can't move through mountains unless you're flying over them, you know, stuff like that. So you won't really have, like, we don't, like, yeah, I mean, sure, you can, if you like, you can do like variations. Like let's say we have an even higher mountain. Like let's say we have like a tall mountains. They could be like, you know, a tall mountain, and that should only be for 0.6. 0.6 is mountain, then it's tall mountain, for example. We go to draw, and tall mountain is gray. Is it gray? Yeah. So now we got tall mountains. Yeah, like each. So here's the tall mountains now. Each, like, you know, cell is either solid or not solid, essentially. So if we go back here and we zoom back in, or we don't zoom out, and we move over, So here, as you can see, like the movement is like locked onto the grid. That's the first thing. The movement is locked onto the grid, because that's kind of the classic like jrpg way of doing things, right? And if we're over here, then we shouldn't be able to go through here unless we have some kind of, you know, let's say we can go through here, or we can't go through the tall mountains, but we can go through the small mountains or something like that, you know. So each cell in the grid is either walkable or not walkable. So if I press up here, I won't be able to go up if those were solid, you know. And it becomes a pretty simple way of checking, because if you press up, we just have to do a check. Like what either you can check like, okay, is this tile a mountain or whatever, then you shouldn't be able to go up. That is actually a pretty simple way to do here, or to implement, I mean, because you can just say over here, like before we try to move, well, let's say we did move here. Now, if move counter is more than 0, that means we did try to move here. And we're gonna get, so we have the position of the player. We can also get the grid position, which is gonna be the player. Yeah, so body position. Oops. Divided by the cell size, which we really should actually get here. Yeah, so that is that, and then we can also round it. All right, so because we know that if we're down here, we should be aligned to the grid, so we should get a whole number anyway. But yeah, now reason why I bring this up, if you do zones but want pixel-based, not cell-based movement as you do, then check can fail, so you would need yeah, but I only do the check if we're so this part is like only if we're currently aligned. Like you do the check before you start to move. The pixel transition is just, you know, it's just so that we can see the movement. Instead of it like moving instantly to the next cell. So here we're basically gonna say like, okay, we got the grid position, we want the offset. That's gonna depend on the direction. If we are at right, that's gonna be, let's say this is a vector, so that's going to be 0, 1, and so on. We got up is, no wait, this is 1, 0, I mean. Up is negative, left is negative 1, 0, and then down is 0, 1, yes. Okay, that's the offset, and then the target square or cell that we want to move to is going to be grid position plus offset, and then we can get that. So we get the map, and then we can say map tiles target 0 plus target 1 times map width. If the tile, so then we can check like if this. And I guess we can add a function here. It's solid. Then we cancel the move. So then we don't actually do the move. Okay. So here we can say is solid. Water, true. Water is solid, so mountain is solid and tall mountain is solid. So everything is solid except planes, essentially. Okay, so now, right, we need like the index. Well, we could do, like get pile. So we need like X. Actually, you know what? Game v2 int usize v, and we can just say X and Y, and then we return tiles X plus Y times self. Alright. So then we can say map get tile target. Alright, there we go. So now we shouldn't be able to move through those things. Oh, there we go. So we can move here, but now we can't move through the water. I see, so you treat the fine-grained movement like an in-between the cells or the actual state you check against up front, and then you allow movement between them. Yeah. I mean, yeah. Essentially, the entity here, this thing has... So essentially, the resolution of the world is not like divided into cells. Like a pixel, you can move up. You can have like, you know, sub-cell like positions of all things, but then the cells are, you know, what's used for collision detection here, and it's a very simple system because you only need to check into this array to check if that specific cell that you're trying to move into is solid or not. So now all of these are solid here, and we can't really move through them. All right, cool. So great. Okay, so what do we want to do now? Well, jrpg is not really anything without like combat and stuff like that. So I'm gonna add components. I'm gonna add like a character component. And we're gonna have this kind of like a very generic like game object, or well, it's what I'm thinking is like here we're keeping things like we have health, for example, probably gonna be an integer because that's usually how things are done. And we're gonna have like max health. I guess you can start like with some smaller number here. We have like level, you know, experience. How about an ease in, ease out? Nah, that's not very classic JRPG-ish. Well, right now it's not clear where the grid is, I guess. I mean, you can look at these blobs of, like, you can kind of see it kind of looks like large pixels. So to me, it's pretty simple to see where the grid is. But if I were to make actual actual graphics here, then it would be even more obvious where the grid is, because then everything is like tiled. So yeah, now it's not really super obvious, but it is obvious. It's gonna be obvious. So health, max health, level experience. Okay, let's start there, because I'm gonna... Yeah, let's start there. Now I want to make... Let's see... Question is, do I want this to be like a screen state? I was thinking having like fighting monsters be a screen state. We could do that. Or battle. You can have a battle screen. Battle states. See, now we're getting somewhere. We have a battle states. All right, let's import it over here. Okay, the battle states, probably we need like enemies. Some games have slots like where the enemies can be, like maybe a formation, and then fill in the slots depending. Yeah. Probably not use like generated textures. I'll probably just make a very simple thing. Actually, you know what? No, I'm gonna do it. I'm gonna do this first. Think about this first here. No, you know what? I'm just gonna do a very simple thing here. All right, this is all screen. We're gonna add a... No, let's actually do black and white here. Yeah. And are you grayscale? No, you're not. Okay, good. So let's configure grid 16 by 16, double dash, view grid. Okay. So here's the tiles that we can make. Now I was thinking that, you know, planes. Oops. Maybe a little bit darker. You know, something like this. This is a plains, essentially. Okay. And then water. There's some water here. Okay. And then mountain. Why is it so different? Alright, and I guess we can have tall mountains as well then. With some snow on top. Let's make it a little bit darker snow. Maybe that's too dark. Okay, there we go. Minimalistic. So this is like jrpg. What? Oh, it was very slow. To source resources. Alright. And we want the tile. This is the tile sheet. Okay, and now we can say map or draw. When we draw the map, instead of doing this, we're gonna get the tile sheet. If we don't have the tile sheet, I guess we don't do anything. And this is actually not color. This is going to be source rectangle. Tall mountain is 48, I think. Oops. No, it's the opposite. There we go. And then instead of doing that, we're gonna draw a texture. No, texture row. Texture is tile sheet. Source is source rec. Destination we can decide. I'm gonna say 0, rotation 0, tint is white. Right, so we need a destination. And I'm actually gonna make this mutable X. So the position is cell size X and Y. Alright. Oh yeah, and the size as well. There we go. Now we should draw. Now we should be drawing the tile map instead. Hopefully, or not, or we are. Except I only see one at the top left. Okay. When are you called? You're called there, so that should be fine. Yeah, classic ultimate map like style, terrain, and some board games. Yeah, exactly. So this is more like, yeah, I was thinking like Final Fantasy, but yeah, Ultima also has the same kind of overworld graphics. Like zoomed out. That was correct, right? Source, destination. Oh wait, destination X cell size. No. X plus Y. Yeah, so times. God damn it. There we go. We got to put in offset as well. All right, let's see. There we go. Yeah, so okay, I have a question for you guys. So when you move, when you see this move, do your screen also kind of go darker, like during movement? Because on my screen, like if I have a lot of black and something moving across the black is kind of taking over a little bit. It's like spilling over a little bit. All right, cool. Right, so that was that. Now I want to. I'm gonna take a shot at making like a very simple battle thing here. So we're gonna have a battle state. The battle state is going to say, let's say we have. Well, let's just make enemies is like. I don't know. Let's just make this super simple here. It's just an array list of enemies. An enemy is something. I mean, it can really be. It probably we want it to be ECS based, but yeah. So this could just be game context. I mean, we don't even need the list. We could just put it in the. We could just put it in the registry, really. So I'm not sure what we put here. Actually, we could have like whose turn it is. So basically, whose turn it is, who has initiative, essentially, I guess. Initiative. And I guess this could be null as well. I'm not sure how to rotate that then. We could have like turn order, I guess. Turn order. Blending from tiles regarding spinning over the background color in those cases often down or slicing the cell into quarters and align the bigger color of each. I'm thinking more. I'm not sure. Like I'm thinking more of my. It's probably my monitor. I was asking you guys if you saw that same effect that I'm seeing. Essentially, everything kind of gets a little bit darker when it's moving because of the black background. Okay. Init. Sure. Let's just return. That shouldn't be doing anything really. And actually, then initiative could actually be a usize that starts at 0. Get current what the hell is that called? Get tourney okay, and this is this, and we return. Oh, you didn't see that? Oh, okay. Then it's just my monitor probably. So if turn order length, well, if initiative is less than this, we can return items initiative. Otherwise, we have to return null. Advanced turn, I guess. Okay. Okay, so we can get whose turn it is and stuff like that. Probably, if we go to character, and I guess we could have like actions, available actions. And I guess we'll have like attack for now. Okay, something like this maybe. Okay. We can also have like setup battle. So setup battle. Now, I guess we'll just randomize in here. We can do that. We can just say like, well, we need like different types. We need like a monster or something. I don't know. I guess we could generate it here. I guess. Oh yeah, we need a name. Of course, a name. Alright, and we'll get some, we got a goblin, it's gonna be, actually we need game. Create entity, goblin, we're gonna add a body at somewhere. do like 40, 120, or yeah. On the, well, yeah, on the left-hand side. Wait, they're usually on the right-hand side, though, right? Or are they usually on the right, left? I don't remember. And then we have size is, I'm just gonna say the same size here. And then we'll add, I'm just gonna add like a renderable rectangle. No, wait. Wait, rectangle, I need size, okay. 1616, and the color is, I guess, dark green. Going character props, terrain-based movement, cost will be nice, affecting the battle itself. Yeah, so the way battles should work in like a JRPG is essentially you get kind of transported from the overworld map to a sub kind of to another kind of scene where you fight out the thing. So the battle scene is like, it's not actually where, or yeah, you when you walk around and you go and get into a fight, you don't get into the fight in the overworld. You go to another scene and there you have the fight. So that it's essentially like a zoomed in version of the map, except usually like in old school like JRPGs, you had like different backgrounds for different areas. So if you were in a plains area, you would get like a plains background image, sort of, and so on. So I'm gonna try to mimic that essentially. Yeah, I mean, yeah, I don't know. I'm just gonna try and make it as I remember the classic like Final Fantasy games for now, and I just want to make this type of game for now, like just make it work. That's step one, and then we can like figure out how to do other stuff as well. Okay, so we have, so now it should show up there, and I'm also gonna add then a, I guess, character, which we don't have here yet. All right. So we'll add that. But then we are grab the goblin character and do some stuff to it. So goblin character, so max health is gonna be, I don't know, 3. Actions, we're gonna append attack, and name is gonna be goblin. Cool. All right, and we'll add this to the turn order. But probably the player is going to be added first. So Yeah, so I'll make, actually I'll make, well, the player character. I guess we'll add like a player character tag. Come on. No, I'm not thinking you're demanding. I'm just trying to respond to your messages. Since you mentioned Final Fantasy that do this, for example, in caves and forests, where is the cost due to low visibility obstacles? I don't know. I mean, some like Final Fantasy 4 has like secret passages in caves. I mean, you usually see everything. You see the whole cave almost. Well, you don't really see the whole cave. You have to kind of walk around. Final Fantasy 2 is like notorious for having a bunch of dead ends with no rewards. Or really bad rewards. Like super large dungeons with like a bunch of dead ends. So I guess you could count that as visibility issues, but because you don't see the entire thing, so you have to kind of guess where to go. Trial and error. But anyway, let's see. Player. Okay, so we could probably, let's get an iterator of player characters. And we are going to go through those. And we're going to add them into the thing. Okay. And then we have a goblin. Okay, so now we should have that. So I'm also going to go to the demo, create player. And we're gonna add a player character. And we're also gonna add a character. I'm gonna get the character. And we're gonna initialize it. So actions is gonna be, or we're gonna append attack. Alright, there we go. Then we're gonna do like, okay, so setup battle. Now we're creating our goblin, we're putting in all the characters in the turn order. I guess we can also set initiative to 0. Whoops, I just quit. Okay. And yeah, so that is our setup. Now we need some kind of system that actually updates the thing. So I guess we could have like an update function here. I know what, actually. Advanced turn. So we increase initiative if initiative equals 0. So if everyone has done their turn, essentially, we now initiate kind of the playing out of the turn. This is how Final Fantasy 1 works. The first Final Fantasy is like everyone chooses their action and then it plays out. So I'm gonna try to do something like that. So basically, and then further, like later Final Fantasies have like a battle timer, stuff like that. But I'm gonna do it how the first Final Fantasy does it. So whenever this loops around, that means we have everyone has chosen their thing. So now we need to change. We need to change like. We need to do like, I guess we might need a flag is executing and execute index. All right. And yeah. So this would essentially, we just say turn or is executing is true and execute index is 0. All right, so when we update, we're gonna say, so basically like if get tourney. Actually, if if we're executing, we need to do something. If we're not, we need to do something else. But here's like the turn thing. So if we have a tourney, which we should have, otherwise it's bad. Then we don't. I'm not sure what to do then, or else return. So if we have someone's turn being here, I'm going to I'm going to check if this is an AI, like a monster. So if tourney has player character, so if it has not player character, if it doesn't have the player character, then it's an AI. So we will kind of choose an action for this tourney. So I guess we could have like chosen actions here, which could also be an array list that corresponds to the things. And so this would be an action from here. So action actually this is like a union enum probably. So let's say we have an attack target. We could also have target, so action attack. So an attack has a target and a source. Okay. Okay, and then we also say, turn order needs to be and over here when we're done with the turn order, I'm gonna ensure. Oh, 1 second here. Okay, I have to attend to a thing here in a sec, but I'll just do stuff until we run out of time here, and then we'll call it a day because I need to eat, and I am currently, my brain is like starting to give up here. Chosen action. So I want you to have capacity of same as turn order, items length, and cache. Alright, and then we wanna say yeah, that should be fine. I'm also going to expand to capacity. We're never gonna like loop through the whole list anyway, so that's fine. Okay, now we have a way to actually choose an action, because we can set chosen actions items, and the turnee, well, this is going to be the current one that has like initiative, and so this would simply be whatever. So basically, if, let's say, well, I'm just gonna say it's an attack, because that's the only action that we have right now. Alright, so attack, and we have the source is going to be the turnee, and the target is going to be some kind of random target from the player characters. So we're gonna have, I'm gonna just say get random player target. And we need game as well. So function get random player target. Actually, this is actually interesting. We could just, it would be cool if we had like get random entity. And so, and then you actually pass in a filter. That actually would be kind of cool to have. That would be a nice addition, actually. That gives us a entity context. I mean, I guess it could technically be optional if we don't find one. And here, what we're gonna do, I'm gonna take this. Also, we need self game. Self and the iterator includes, excludes. Now the question is, can I count this? Well, I guess I can count it if I iterate through all of them first. There's probably a way to... Do I want to construct a list as well? Yeah, let's just do a super naive here. Then we have the random. It's going to be self random uint less than length, and we're gonna reset, and then we're gonna do next, and then we're gonna say like while up to length do get the next thing. So let's say 0, it will do it 0 times, right? So then we return next. But what about the maximum? If it's like, let's say it's 10 things, this goes up to 9. No, this is R, right? So then it goes from 0. So that's 9. So it goes. This is gonna happen 9 times, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. And then, but there are 10 entities. So then that will be the 10th entity. And also if R0, we don't do this, and that's gonna be the first entity, right? Okay. Okay. So now we can get a random entity that has the player character. Cool. Right. And then if it's the player's turn, we have to kind of wait for the player to do things. So I'm gonna make a function that says like get player characters get player turning, maybe, and this gives us a thing, maybe. Okay, depending on what's happening. So this will be I guess we'll get tourney and then return. Well, no, if tourney has, well, okay, or else return null. If tourney has a character, return tourney, otherwise return null. I'm not sure if we'll need a specific thing here, but I'm thinking of how this is going to be used now that as well. So if we're executing, we'll do something. If otherwise we're trying to decide on what's to do, the AI just attacks a random player target. Otherwise, we will basically just continue updating. I guess the player that is currently choosing, also we can return here. The player that's currently, so down here we could do like inputs for the things, or that could be done from the controllable as well. To say that we're currently choosing an action from the action list. So we could have like selected action, for example. And that's a use size. And then we can also have selected target as well. I'm just gonna put this in here. So if is key pressed down, or sorry, I guess S, then. So I didn't even ask if it will be multiplayer. No. I mean, NPCs are probably, yeah, NPCs is probably, you know, it's a thing. No, during a battle there's no like outer world events happening. Like it's basically freezing time everywhere else, essentially. Like the classic like jrpg is extremely like it's not like dynamic like that. It's pretty rigid. It follows you know, it's more like following a story more than a lot of procedural things happening. But yeah, that's a cool idea though. Like, let's say there are roaming enemies, and if you fight an enemy that's close to another enemy, they might join up during the fight. That's a cool idea. Okay, so here we are going to say that selected action plus equal to 1, or depending on like the mode, I guess, select mode. Let's do, so we could actually, so we can, no, we just need like, so either, so it's selecting an action or a target, and we'll start with action. Okay, so if select mode is, I guess we'll switch on it. If it's an action, we'll do that. Come on. Selected action, we'll do 1. Also, mod number of actions available. That's going to be like turnies, you know. Let's get the character. So this is going to be like character, actions, items, length. Whoops. Okay. And if we're selecting a target, then it's gonna be like selected target, but we run target mode by turn order items length. Alright. And then we essentially just copy this, do like else if, no, sorry. I just have to make an errand here. I'll be back in, well, actually, you know what? I'll probably have to go now as well. But yeah, this was actually real fun. I've always wanted to make like one of these kind of very simple, like old school JRPGs. So I'll probably continue with this next stream. But yeah, that's gonna be it for this time. So thank you very much for watching.